today from the chapter optics we discuss the next point, which is Lensmakers equation. In a previous topic we discussed the refraction due to the single curved surface. There we determine the formula N2 minus N1 upon R. N2 minus N1 upon R which is equal to N2 upon V minus N1 upon V. This equation we derived in a previous topic. Now from this equation we derive the next point, that will be Lensmakers equation. Now for that we have required the curved surface. Those curved surfaces are consider as lens. This one is a lens. This is the lens having the first curved surface, and this is the lens having the second curved surface. A line which passes through it and from the center and the pole, it is called as the principal axis. On this principal axis, let's consider here the first curved surface having the center C1. The first curved center having center C1, and this second curved surface having center C2, where C1 and C2 be the two points where the centers are present. Let's consider that this first curved surface having center C1 and this second curved surface having center C2. Here C1 and C2 with the center, an object is placed at this point O. Let's consider O with the object. This object is placed at any one point on this principal axis. We consider here on any one point. When an object is placed here, that distance is corresponding distance is considered as U, where this distance is termed as an object distance, which is represented by the symbol U. Here R is the R1 will be the radius of this first curved surface, and R2 will be the radius of this second curved surface. Now here we consider that this lens having a refractive index M, and here outside that there is a medium here having refractive index 1. That's why we separate the lens separate the two mediums. This is having lens having medium, we are having refractive index N, and this first curved surface having 1 with a refractive index of the medium. Now we consider that O will be the point where an object is placed. P is the pole. P is the point where the pole, or we say at this position. Now we discuss the first point from this. When and consider this lens having radius above curvature. Now here we write first of all the leveling. For that we consider that N will be the refractive index of the medium. P will be the pole. C1, C2 be the center of curvature. Center of curvature of first curved surface and second curved surface. R1 and R2 be the radius, R1 and R2 be the radius of the first curved surface and the second curved surface respectively. Now here from this section, here O will be the object. O will be the point where an object is placed. That object is placed, that distance is corresponds to be considered as a U. Now we consider that here a point object is placed at point O. A point object is placed at this point O, which is at a distance U from the P. Then this OP is equal to, we write here, OP is equal to U. That is the distance. That distance we consider as minus U because it is left side of the pole. Now here, this first surface, now we discuss about the only one curved surface. If there is only one curved surface is present, here we say that N1 is the first curved surface. N1 will be the refractive index of the first, and N2 will be equal to N. That means this glass surface having refractive index N. of a lens, then N2 is equal to N. Now we consider, we make the equation for it, that equation for the first curved surface, for the first curved surface. Now here, object OP is present at this position, a ray is incident from this point, which is axial or to the principal axis, it moves in the straight direction. There is another ray, is OA, which is incident at this point. When this ray is incident, it produces its image at this point I1, and this distance we consider as V1 will be the distance up to this position. Now here the image is formed due to the first curved surface. Image is formed due to the first curved surface. Now according to this data, we make the equation. That equation will be considered yesterday or in the previous topic, that N2 minus N1 upon R will be N2 upon V minus N1 upon U. For this equation number 1, now we substitute the corresponding value. For the first curved surface, this R, instead of R we substitute R1. R1 will be the radius of this first curved surface. Here, object distance, instead of this U, we substitute as a U1, and instead of V, we substitute as V1. And also we say that the first curved surface N1, the first curved surface having N1 having refractive index 1, and N2 is equal to N. N2 is equal to N. Now substitute all these values in this equation. Then the above equation becomes N2 minus, instead of this N2, we substitute N minus 1 upon R. Instead of R, we substitute as a R1, which is equal to N2. N2 means N upon V. Instead of V, we substitute as a V1, will be the image distance due to the first curved surface, minus N1. N1 having the first curved surface having refractive index 1 upon U. Now, this one is the first equation that we discussed, and call this equation number 2. Now we discuss about the second curved surface. Here, now we consider that this one is the second curved surface which is present now. This one is the second curved surface. Here, this one is the first image. For this second curved surface, R2 will be the radius. Now, here we write for second curved surface. For second curved surface of this lens, we write here, instead of R will be the radius. For the second curved surface, the radius will be R2. U is the object distance. Now, this image is formed due to the first curved surface, which acts as an object for this second curved surface. And due to this curved surface, the final image is formed on the same side, which is at a distance R. Which is here, final image I is produced, which is at a distance V from this position. Therefore, we say that this V1, this image I1 act as an object for this second curved surface, where we say that object distance is considered as a V1, and this V, that means final image, that final image is at a distance V. Instead of V, we substitute as a V. And for this second curved surface, now we change these categories. Here, this one becomes the first curved surface. Here, N1 is equal to N, and here this air medium, that is N2 is equal to 1. Therefore, we write here N1 is equal to N and N2 is equal to 1. Now, substitute all these values in the above equation, where we say that equation 1 implies, here equation 1 implies as, here also we write equation 1 implies like this, N2 means 1 upon N, 1 upon N, 1 minus N1 means n upon this r becomes r2, which is equal to n2. n2 means 1. n2 means 1 upon v, where final image is obtained at point v, minus n1. n1 is equal to n. n1 is equal to n upon image distance or object is placed at a distance v1. Here we write minus v1. Now call this equation number 3. Now from the equation 2 and 3, here we rearrange this equation number 3 as like this. Here we make minus sign common from this. Minus sign common from this, we write n minus 1 upon r2, which is equal to 1 upon v minus n upon v1. Call this equation number 3, or we say as a 4. From equation 2 and 4, we subtract both these equations, and from equation 2 and 4 we write n minus 1 is common from there. Now in the next step we write here from equation 2 and 4 we write here, from equation 2 and 4 we write like this: n minus 1 is taken, n minus 1 upon r1. This one is LHS. We add both these equations. Therefore, n minus 1 upon r1 minus here n minus 1 upon r2, which is equal to, we add on the RHS, n upon v1 minus 1 upon u plus 1 upon v minus n upon v1. Now at this time we say that this minus n upon u, this minus 1 upon u, and here this one, this plus n upon v1 and minus n upon v1 will get cancelled. Therefore, we write here n minus 1 will be taken as common. In a bracket, we write 1 upon r1 minus 1 upon r2. 1 upon r2. 1 upon r1 minus 1 upon r2. n minus 1 is taken outside from this bracket, which is equal to, here 1 upon v is a plus sign and minus 1 upon u. Having minus sign, we will write it as better. Now, call this equation number 5. Also, we know that if object is placed at infinity, if we say that object is placed at infinity, here its image we got at the point F. Its image we got at the point F. Then we write this corresponding equation n minus 1 into 1 upon r1 minus 1 upon r2, which is equal to 1 upon v. Instead of this, we write 1 upon f minus 1 upon u. 1 upon u means 1 upon infinity. Then this 1 upon infinity becomes 0. Therefore, we say that which will be equal to 1 upon f. For this equation number 6. This one is called as the Lensmakers equation. This is about the topic. We say that the Lensmakers equation. This equation is termed as a Lensmakers equation. Now, from this topic, the question is asked like this: derive Lensmakers equation. You may draw first of all diagram, then write labeling, which is given here. After that, labeling, you may write consideration, consider a lens, all this consideration. Then from this equation, you may write up to the last step. In this way, we discuss about the Lensmakers equation. Okay.